In this video, we'll be finding the area of a disk of radius 1. So to get started, we need a function or functions that give us the boundary of that disk. So do you remember from high school what the equation of the circle is? This is a circle of radius 1, so the equation is x squared plus y squared equals 1. General r squared, but in this case 1. Now I want to use either vertical or horizontal. You get to pick. It doesn't really matter with the symmetry here. It's quite nice. I think vertical is a tiny bit easier, so let's do vertical. So the first thing I need to do is I need to rewrite that equation as y equals a function of x. So we get that y squared is 1 minus x squared. And y is then either the positive square root or the negative square root. Alright, so we do get two functions, even though we had a single equation. We have, let me draw it. The positive square root would give us a positive y, so will give us the top part of the circle. And then the negative square root would give us a negative y. Pretty bad circle, but you get the picture. We have these two curves, and we're looking for the region bounded between them. Now we know the radius is 1, so that value of x is 1, that value is minus 1. And we're ready to set up the integral. I'm looking for vertical slicing, so top minus bottom. Now wherever you draw your vertical stick, top is going to be on blue, bottom is going to be on green. So top we said was positive, square root. Bottom was minus the square root. And the x value go from minus 1 to 1, so minus 1 to 1. If I simplify this, I get the integral from minus 1 to 1 of 2 times this. Alright, are we done? No. We're not done because we're not asked to set up an integral, we're asked to find the area. So that means we need to evaluate this integral. It's not a basic integral, we don't have an antiderivative for this sitting somewhere in our brain, so we need to do some sort of substitution, integration by parts. Well, there's only one and it wouldn't work. So what I need to do is substitution. 1 minus x squared will not work because I don't have an x with my dx. So we're a bit stumped. One thing you might think of is, well, this looks a lot like the derivative of arc sine. So maybe, and we're trying this out of despair at this point, so maybe I could try x is arc sine, theta is arc sine of x. And then if I look at what d theta would give me, it will be 1 over square root of 1 minus x squared dx. And so if I want to replace dx on my integral, I'll be able to replace it by square root of 1 minus x squared d theta. Alright, so let's make this substitution. I'll get the integral, 2 stays the same. Let's leave the square root of 1 minus x squared on place. And dx, we said, was square root of 1 minus x squared d theta. And so I get the integral of 2, 1 minus x squared d theta. I need to change the bounds, so arc sine from minus 1 to 1, so arc sine of minus 1, arc sine of 1. I need a tiny bit more space here, tiny bit more room. Arc sine of 1 is pi on 2, arc sine of minus 1 is minus pi on 2. Now you're thinking this is an easy integral, but the problem is we haven't changed our variable completely, so we're not allowed to integrate yet. Our new variable is theta, but the function is still in the old one, so I need to work a bit harder. Now if I go back here, what's special about arc sine is that it's the inverse of sine. So if theta is arc sine, then x is sine of theta. So I could place that right here. And so I'm getting the integral of minus pi on 2 to pi on 2 times cosine squared theta d theta. Now this integral we can solve. We have a trig identity to do it. It was part of our even odd play with sine and cosine. So now this is and we're almost there. We have now have something simple enough so that we can integrate it. So we need the integral from minus pi on 2 to pi on 2 of 1 plus cosine 2 theta d theta. And so that's theta plus the integral of cosine is sine. And because of that 2, I need an extra 2 here, and I'll go from minus pi on 2 to pi on 2. No integrals anymore, that's excellent. We just need to plug in the 2 bounds. So we'll get pi on 2 plus sine of pi. So that's what I get when I plug in pi on 2. If I plug in minus pi on 2, I get this. Pi on the trig circle is 180 degrees, so it's this way. That means this is going to give you 0. The y value would be 0. This one would be 0. If you don't know your trig circle super well, if you want to double check, you can always use your calculator. So here I get pi on 2 plus pi on 2, I get pi. We just proved that the area of a disk of radius 1 is equal to pi.